Your team ships a big architectural change. New service, new data model, months of work. 6 months later, production is on fire, and someone asks, "Why did we do it this way?" Slack threads are gone. The tech lead moved teams. The Jira ticket links to a dead Confluence page. A new manager presses, "Why this design, not the other one?" And the honest answer is, it seemed reasonable at the time. That gap between what you decided and why you decided, it is where outages, rework, and cross-team friction live. You can't debug trade-offs you never wrote down. Experienced engineering orgs don't trust memory or chat logs for significant technical decisions. Google, Meta, Uber, Stripe. Different cultures, same pattern. They use RFCs, short structured proposal documents written before you commit. RFCs force you to clarify the problem, lay out options, and get focused feedback. And they leave behind a durable record of the rationale, so future teams don't have to reverse engineer your thinking from code diffs. In this video, we'll walk through exactly how to write and run RFCs so they get read, drive alignment, and catch bad ideas before you write a single line of code. Let's get precise. What is an RFC? An RFC, request for comments, is a short, structured proposal document you write before making a significant technical decision. The timing is the whole point. You write an RFC when you're saying, "Here's the direction I think we should take. I want feedback before we commit." The decision is still movable. That's different from an ADR, an architecture decision record. An ADR comes after the decision. Its job is to record what you chose and why, not to debate the choice. So the split is simple. RFCs propose and invite comments. ADRs record and explain decisions that are already made. Most large engineering orgs have both. They use RFCs for cross-team alignment up front, when changing course is still cheap. Then they use ADRs or similar docs to capture the final call, so future engineers can see the outcome and the reasoning in one place. Why bother with RFCs at all? Why not just talk in Slack and move on? Because the RFC process does 3 jobs you don't get for free. First, it forces rigorous thinking. Writing down the problem, the design, the alternatives, and the rollout exposes fuzzy logic. If you can't explain the idea clearly in under 5 pages, you probably don't understand it well enough yet. Second, it gives stakeholders a structured way to weigh in. Instead of scattered comments across chat, email, and hallway conversations, everyone reacts to the same document, the same problem framing, the same set of options. Third, it creates a durable record of the design rationale. Months or years later, someone can open the RFC and see not just what you did, but what you considered, what you rejected, and why. Those 3 jobs, rigorous thinking, structured input, and durable rationale, only work if the RFC is designed to be read and the process around it is clear. That's what we'll break down next. None of this matters if nobody reads your RFC. So here's a practical rule. Keep your RFC under about 5 pages. Most engineers and managers will not read a 15-page design novel. They'll skim, miss key trade-offs, or quietly ignore it. Long docs fail the gets read test. Instead, use a tight, predictable structure. 1. Summary. 2. Problem statement. 3. Proposed solution. 4. Alternatives considered. 5. Rollout plan. 6. Open questions. This lets a busy VP get the gist from the summary. It lets reviewers jump straight to the problem and proposed solution. And it channels comments into the sections that actually need discussion, instead of turning the whole doc into a bike shed. Let's go section by section, starting with the summary. The summary is 3 to 5 sentences that state what you're proposing, why it matters, and the expected impact. Write it so a busy executive can read only this section and still understand the essence of the proposal and its upside. That means being concrete about impact in business or system terms. For example, this will reduce order processing latency from 2 seconds to 200 milliseconds, for 95% of orders. Notice what's packed into that one line: a before value, an after value, and a percentile. 2 seconds down to 200 milliseconds at the 95th percentile of orders. That level of specificity forces you to think through what better actually means and makes it easy for leaders to decide if it's worth doing. Next is the problem statement, and this is the most important section in the entire RFC. If reviewers don't agree on the problem, they can't meaningfully evaluate any solution. You'll argue about architectures while secretly disagreeing about what hurts. Your job here is to describe the pain precisely, backed by data. Use hard metrics, error rates, latency percentiles, developer hours wasted, customer complaints. For example, checkout error rate has increased from 0.2% to 1.5% over the last 30 days, affecting roughly 12,000 orders. Or, P95 search latency increased from 400 milliseconds to 1.2s over the last 14 days. Support tickets about slow search doubled from 50 to 100 per week. And always include the cost of inaction. What happens if you do nothing? Does on-call page volume keep climbing? Do SLAs get violated? Is revenue at risk? The cost of inaction is part of the justification for any change. A sharp, quantified problem statement is what gets reviewers leaning in instead of pushing back. Once the problem is clear and everyone agrees it's real, then you talk about the proposed solution. Here, you describe the architecture at the right level of abstraction. Not every line of code, but enough detail that a reviewer can see what's changing and how it addresses the problem. Call out which components change and which stay the same. If other teams depend on an API, spell out the contract, example requests, example responses, and the guarantees you provide. Idempotency, latency targets, error semantics. If the proposal spans multiple services, include a system diagram. Boxes and arrows are often more informative than 3 paragraphs of prose. The goal is simple. Someone familiar with your stack should be able to read this section and say, I see how this design attacks the problem, and I know exactly which parts of the system are impacted. A single proposed solution isn't enough. Reviewers need to know, did you actually explore the design space, or did you just write up your first idea? That's what the Alternatives Considered section is for. List at least 2 or 3 alternatives you evaluated. For each one, describe the approach and explain why you rejected it. Be honest. If an option was a close call, say so. This builds trust. For example, Alternative A. Scale the existing service vertically. Rejected because hardware cost would increase 3x and it doesn't address the long-term throughput limit. Or, Alternative B. Move to a managed service. Rejected due to data residency constraints and high migration risk in Q4. This section proves you understand trade-offs: performance versus cost, complexity versus risk, speed versus safety. You're not fixated on a single idea. You're choosing a direction with your eyes open. A design that looks great on a whiteboard can still be a disaster in production if you can't ship it safely. That's why the rollout plan is critical, especially for senior-level proposals. Here, you explain how you'll deliver the change incrementally. What's your feature flag strategy? How will you start with, say, 1% of traffic, then 10%, then 50%, before going to 100%? What's your rollback plan at each step if metrics go red? Be explicit about what you'll watch during rollout: error rates, P95 latency, resource saturation, and key business KPIs like conversion rate or successful checkouts. This section reassures reviewers that you're not just dreaming about an end state. You've thought through the path from today to that end state, and how to avoid taking down the system along the way. The last core section is open questions. This is where you list what you're still uncertain about and where you actively want input. Being explicit about open questions does 2 things. First, it focuses reviewers on unresolved issues instead of nitpicking settled parts of the design. Second, it signals that you're comfortable acknowledging uncertainty. That's a sign of maturity, not weakness. Good open questions sound like, should we reuse the existing queue or provision a new one for isolation? Or, are there compliance implications of storing this additional field for 90 days? Or, is our assumed 200 millers P95 latency target realistic for this dependency? You're telling reviewers very clearly, here's where your expertise is most valuable. Start here. Writing the document is only half the work. The other half is how you run the RFC process. Start by setting a clear review period, typically 5 to 7 business days. Short enough that RFCs don't linger forever, long enough for busy people to respond. Assign 3 to 5 explicit reviewers who bring different perspectives. Downstream consumers, the platform team, security, SRE. Don't just blast a link to a mailing list and hope someone bites. During the review window, collect comments, respond to them, and then synthesize the feedback into an updated proposal. Call out what changed based on which concerns. After that, schedule a short decision meeting, about 30 minutes. That meeting should end with one of 3 outcomes: approved, approved with modifications, or send back for revision. By the end, everyone should know 3 things: what was decided, what changed because of feedback, and what happens next. What goes wrong in practice? There are a few common RFC anti-patterns that quietly kill the process. First, the rubber stamp RFC. You circulate the document after you've already started building. At that point, reviewers feel like they're just being asked to bless a done deal. They disengage. Second, the novel RFC, a 15-plus page opus that nobody reads. It looks thorough, but it fails the under 5 pages, gets read rule, so critical feedback never shows up. Third, the ghost RFC. You publish it, people leave thoughtful comments, and then nothing. No responses, no synthesis, no decision. Reviewers learn their input doesn't matter, and they stop engaging on future docs. Finally, the consensus trap. You wait for unanimous approval instead of aiming for informed consent from key stakeholders. Decisions stall because one person is busy, hesitant, or mildly uncomfortable. Spotting these failure modes early is the first step to designing a process that avoids them. So what does a successful RFC look like in practice? Effective RFCs share a few principles. They clearly state the ask up front. In the first paragraph, you say exactly what you need: approval, feedback on specific questions, or alternative suggestions. You don't bury the ask on page 3. They anchor everything on a strong, data-backed problem statement. Remember, if reviewers don't agree on the problem, they can't evaluate the solution. They include at least 2 honest alternatives with real trade-offs, not strawmen you can easily knock down. This proves you actually explored the design space. They define explicit review timelines and approval criteria, like 5 to 7 business days, 3 to 5 named reviewers, and a decision of approved with modifications, send back. So RFCs don't drift in limbo, and they treat rejection as a success. A rejected RFC means you avoided a costly mistake before writing code. That's a win for the system, even if it stings the author for a day or 2. One more nuance. Not every decision deserves a full-blown RFC. You want to match the weight of the document to the impact of the decision. For significant cross-team decisions, new services, major schema changes, platform migrations, a concise RFC with the 6-section structure we've covered is appropriate. For smaller, localized decisions, like tweaking an internal API used by a single team, a 2-page ADR or short design note may be enough. If you write a 20-page RFC for a minor change, people will tune out and the next important RFC will suffer. If you make a major cross-team decision with no written rationale, future teams will pay the price in confusion, rework, and risky migrations. The goal is to use just enough process to make good decisions. No more, no less. It's also important to keep the role of an RFC distinct from a specification. An RFC is meant to propose a direction and gather feedback. It answers, what problem are we solving? What approach are we taking? What trade-offs did we consider? And how will we roll it out? It is not meant to fully specify every implementation detail. Detailed behaviors, edge cases, data models, and API schemas usually belong in a follow-up design or spec document once the direction is agreed. If you cram the full spec into the RFC, the doc becomes long, hard to review, and much more likely to be ignored. Think of the RFC as the decision-making document. Once it's approved, you can write a more detailed design or spec that engineers will implement against, while referencing the RFC for the rationale behind the direction. Let's pull this together. RFCs are short, structured proposal documents written before major technical decisions. They force rigorous thinking, give stakeholders a clear way to weigh in, and leave a durable record of why you chose one design over another. An effective RFC stays under about 5 pages and follows a predictable structure: summary, problem statement, proposed solution, alternatives considered, rollout plan, and open questions. You run the process with clear review windows, 5 to 7 business days, 3 to 5 explicit reviewers, and a 30-minute decision meeting that ends in one of 3 outcomes: approved, approved with modifications, or send back for revision. Along the way, you avoid anti-patterns like rubber stamp, novel, ghost, and consensus trap RFCs. You match document weight to decision impact, and you remember that an RFC is a proposal, not a full spec. Do this well, and even a rejected RFC is a success, because it means your organization avoided a costly mistake before writing any code. The result is not more paperwork. It's faster, clearer, better technical decisions that your future teammates will thank you for. If your team doesn't have an RFC template yet, start simple. Use the 6 sections we covered, set a 5 to 7 day review window, and run one real decision through it. You'll learn more from that single RFC than from any process doc you could write about RFCs.